You're here because of asteroids, and Jason, who comes out of NASA's headquarters in D.C. at 300 East Street, I understand. Southwest. Anyway, so Jason's come here to speak with us about finding and planning for asteroids that may squash us like bugs or like other species who have been squashed in the past.
And thanks for the invite. What a great opportunity. We announced the Asteroid Grand Challenge back in June, and it's a new way of thinking and doing business at NASA, so it's a great privilege. This will be the first public audience since the announcement that I've gotten a chance to speak to, so thank you. Space, for a long time, has captivated our imagination. And through space exploration, we have the ability to radically change our future. And at the same time, do things for the benefit of all of humankind. About a little over 65 million years ago, there was a very bad day here on planet Earth. And these poor folks didn't really have any ability to do anything about it. And really what I'm here to talk about is a natural disaster that we actually have the ability to do something about. We can change our fate, and it really only requires the will to do so. This is not new. It happened over 65 million years ago, but it happens more often than I think people ever realized. Earlier this year in February, 15th of February, we were anxiously watching DA-14 pass by, very close asteroid pass of the Earth. And then lo and behold, out of the sun comes a 17-meter asteroid. Hits in Chelyabinsk, Russia. You can see here a crater from a 50-meter asteroid, the remains of which are in northern Arizona. The equivalent of 10 megatons of TNT. So this stuff happens. One need only look at the surface of the moon. We're in a very, very active neighborhood. Statistically, folks might say, likelihood is small. The reality is that we don't know where that many of these smaller asteroids are located. So NASA announced with the FY14 budget an asteroid initiative. So to kind of give you a sense of how this fits into the overall NASA program, NASA has an overall strategy to study asteroids. They're very interesting for lots of reasons. Origins of life, origins of the solar system, planetary defense, resources for here on Earth or exploration. And so NASA's had a whole lot going on in the asteroid realm. But in 14, we announced two aspects of an asteroid initiative. The first, which you've probably heard quite a bit about, is the idea that we would find a 7 to 10 meter non-threatening asteroid, send a spacecraft through a solar electric propulsion system out to this asteroid, capture that asteroid, redirect it around the moon in a translunar orbit, and then send humans on the SLS Orion program that we are currently building at NASA to go explore it and bring samples back. Got a lot of press early in the year. The excitement of sending humans to go and explore a body that hasn't been touched before. The other aspect, though, and the one I'm going to focus on today, is the Asteroid Grand Challenge. And that is focusing on the potentially hazardous threats that every single human being and every life form on this planet ought to have some interest in. So digging down a little bit more deeply into the asteroid initiative, we see that there are a couple of areas of overlap between the Grand Challenge and the mission. In terms of detection, absolutely have to find a target for humans to go and explore, while at the same time we have to find what is threatening out there and might impact us. So there's overlap between the two aspects in detection. And then the second, maybe not as obvious to folks, is that when you go out and explore, you're going to have proximity operations. You're going to have to learn how to operate around this foreign object. The same type of knowledge might be useful in terms of a mitigation solution. Are you dealing with an asteroid that a gravity tractor might work, where you have a mass that helps pull, slowly nudge this threatening asteroid off of its course, thereby saving the planet from getting impacted? So there's some obvious areas of overlap. Additionally, the Grand Challenge is focusing on engaging a community that we don't normally talk with. NASA has a tradition of getting a mission, having requirements for that mission, executing to those requirements through either grants and contracts that are let with a community that we typically work pretty well with. The twist here, and one that I can say thanks to Ames, the neighbor just down the road from here, and the NASA Center that really does push the envelope in terms of partnership and participatory engagement, is that we have an opportunity to speak with folks that we don't normally talk with about these kinds of things and start to pull in ideas that we wouldn't have before. And I'll give some examples of what that looks like. That's, in a scale this big, that's new for NASA. So here we are with the actual challenge statement. And you can see that it is grand. It's bigger than NASA's ability to handle on its own. Finding all asteroid threats to human populations and knowing what to do about them. That's even really beyond our mission. In terms of mitigation and deflection, that's not our bailiwick. But what the Grand Challenge enables us to do is take an area that we do a lot of work in and start a conversation broadly, a global conversation at that, and invite others in to help with this effort. Because as I said, this is an issue that every life form on the planet should have some interest in. So the way we're addressing this Grand Challenge is in 5 areas. Detection, we have to find where they are. Tracking, we've got to know what their orbits are, so that once you find it, you need to know, is it on a path to hit the planet? Characterization, what's its spin rate, what's its size, what's its shape? And then as you start to move into some of the other interesting aspects of asteroids, what's it made of? What kind of materials might be there? Is there water? Fuel source for deeper exploration? Minerals? And then finally, mitigation. Once we find something that's on its way, we need to figure out of the multiple choices that we have now, how do we deflect it and mitigate its impact? And then woven throughout all 4 aspects is a communication piece. Because thanks to Hollywood, there are some wild ideas on how one might solve this problem. And part of this effort is to communicate clearly what is factual and what solutions might work. So to dig in a little bit more deeply, if you look at that circle, there's a chunk of the circle that's not filled in. The rest of that circle those are slices of people that are already doing work. NASA's doing a lot of work to find potentially hazardous asteroids. Starting in '98, we've had a very serious program, the Near Earth Object Observation Program. has found over 95% of the 1 kilometer or larger asteroids. Those are the planet killers. The challenge is that we're only finding about 1,000 a year, and there are potentially 1 million out there down to 30 meters or larger. And as I said earlier, Chelyabinsk, that hit in Russia, that was 17 meters. About 1,000 people seriously hurt, windows blown out, millions of dollars worth of damage. So we're looking for roughly twice that size, because that could really devastate a city. So there's opportunity here to build upon the work that we're already doing. We recognize there's a need. So beyond just external contributors to this effort, there are potential contributors. And in fact, the third listed there is maker community. It's kind of a new one for NASA to think about. I'm off to Maker Faire in New York City this weekend, and I know that Ames has had a big presence at the Maker Faire here, and have been engaging with folks about a conversation. Are there ways that we can improve mirror grinding? Are there ways that we can improve telescope mount builds? Can we redesign, re-engineer? Can we lower the cost of what it takes to build ground-based detection? I mentioned Hollywood earlier as well. I'm very pleased to say that there's some serious interest in focusing on a very factually based asteroid film. And so in terms of the communication piece, to be able to explain to folks what's really at stake here, and what really do we have the ability to do at this point, and what is that gap that we need to start filling. An interesting opportunity to partner there to bring science fiction and science fact a little bit closer together. An example of partnership potential here. Light curve analysis is really hard to do. You need to be patient, and you need to have telescope time with the equipment to be able to track a quickly moving asteroid through the night sky throughout the night. Because basically what you're doing here is you've got your telescope and you've got a CCD taking images, and over time you're determining the change in the reflected light. Albedo changes over time. You can start to get a sense of what the spin rate is. Eventually you can figure out what the shape of the asteroid may be. Mathematically difficult. It takes, again, a lot of telescope time. And so as we focused our energy into detection, because that's the first problem we need to solve, it's expensive to spend time on those telescopes tracking and characterizing. So there are about 50 to 100 amateur astronomers that are doing near-Earth asteroid light curve analysis. So as I stepped into this program, I thought, this is an immediate place that we can change the conversation. You can get a published paper out of the work that you do on a light curve analysis. So by broadening this conversation and saying to folks, we've got a serious problem, we'd like your help addressing it, we'll collaborate with you to figure out how to make light curve analysis either easier or more accessible, and you can contribute meaningfully to this cause and potentially get a published paper out of it. So as a first step to build off of the momentum that we're creating, engaging university students is one of the first things that we are looking at doing. Shape model. I mentioned characterization. Shape models are also tough. It's not an easy problem. And so is there a way to throw a challenge out to a community and say, here's our requirement, here's the state of the art right now, can you help us? Kind of a technique of using the prize and challenge authority that NASA has to engage folks with the potential of getting some prize money, if not great recognition. And then finally, as an obvious next step would be space-based observation. I believe Ed was here, Ed Liu from the B612 Foundation was here previously and is coming back later this month? November 4th. Come see Ed. B612's got a plan to send an infrared telescope up into a Venus trailing orbit and radically improve the number of asteroids that we can discover each year. And so space-based observation really would enable us to get to a place where we can increase our detection rate and enable us to find those that are getting smaller down to the 30-meter size, because 30 meters is tough. I said we found 95% of the 1 kilometer or larger, and we've had amateur help with that. The difficulty, though, now is that as you get smaller, they're fainter, they're moving fast, and to expect the amateur community to help us with detection is really not very realistic at this point. And so that's why we focused on light curve analysis as a way to engage the amateur community to help here. But it's really getting into space that will enable us 24-hour viewing. It'll get us away from the sun and keep that blind spot from impacting our ability to search. Does that mean that there might be small sat solutions? I'm talking a little bit earlier at Ames with some of the folks there about small sat solutions for observation. And in fact, just had somebody pop up with an idea of using space station as a platform as well. So space-based observation is really the next phase for us to get serious about our detection effort. I mentioned Ed and the B612 Foundation. This is one example that we anticipate using at NASA to engage the community. Here's a public-private partnership. We have an unfunded Space Act agreement. That's a legal agreement between NASA and a private entity. In this case, it's a nonprofit whose mission is very well aligned with NASA's. And the idea is that through a Space Act agreement, through this partnership mechanism, you have a shared future that you'd like to see become real, and you align your expertise and contribute accordingly. And so NASA provides some science and engineering support, as well as the use of the Deep Space Network to receive data from the mission that they have proposed to fly. So the Space Act Agreement is a great mechanism for us to look to other organizations to partner with and enable a collaboration that's beneficial for both. I mentioned briefly prizes. So NASA has prize authority. Pretty special opportunity for us to have no-year money. For those that aren't familiar with the government budget cycle, usually has 2-year life, but prizes can take quite a long time, and so we have the ability to have some funds that wouldn't expire. And so here you see an image of a Centennial Challenge prize winner. This was the Green Flight Challenge, and the challenge was to fly 200 miles in less than 2 hours and less than a gallon of gas per person. And Pipistrel, pictured here, won $1.3 million and flew over 400 miles in that 2-hour period. So here's an opportunity to leverage a need that we have with funding that we have to enable innovation in the marketplace. There was another entry that broke the 200-mile barrier, but they didn't break the 400, and a number of others that didn't win. But here's an example of individuals, whether they're partnered teams or individuals themselves, because of the opportunity, are willing to spend their time and their own resources to come up with solutions to technological problem that we have and hadn't really focused on, and have a payday where eventually a company can come out. In fact, there is a Centennial Challenge winner for an astronaut glove. Very difficult technology challenge to enable an effective glove when you're in zero G and you've got a vacuum that you're fighting against and a pressurized suit to be able to have the ability to grasp and use tools. Really tough. So there was a Centennial Challenge for that. And now there's a company, the winner of that Centennial Challenge has a company that is building suits. So the idea here is, are there technological challenges that we can identify in this grand challenge that we can spark some innovation from folks that maybe not thinking about this right now, but would be willing to spend their time and energy for the contribution? Another mechanism for us in the Grand Challenge is crowdsourcing. And you guys are probably quite familiar with it. The idea here is that you leverage the crowd to help with the problem. The Zooniverse platform, through Galaxy Zoo, radically cut the time it took to characterize and define types of galaxies out there. And so we have lots of data through our asteroid search. Planetary Resources, a mining company, wants to exploit the resources of asteroids, had a Kickstarter campaign, raised almost $2 million, and because they raised so much, they announced that they were going to be able to do an asteroid zoo. And so through a partnership with the Catalina Sky Survey, that's a survey out of Arizona that has years worth of data, the thinking is by opening up that data to the crowd, we can have eyeballs on that the algorithms might have missed. Some potentially hazardous asteroids there. Are there other ways that we can use the benefit of a crowd to help with this data problem? And finally, really the fourth area, it's related to the light curve analysis piece, but it's citizen science. And this image here predates NASA. I think this image is 55 or 56. And you're looking at Biloxi, Mississippi, Operation Moonwatch. The idea was brainchild of a gentleman at the Smithsonian Astrophysical Observatory, and had tremendous battles with the science community back then, because his idea was there are going to be all sorts of human-made objects circling the Earth, and we're going to need to know where they are, what they are, and we don't have any ability to do that right now. So I want to go out and train the citizenry to be able to help with this effort. And so they did that very thing. Here you see a training in Biloxi where they're showing folks how to look and how to contribute. And if you do a search on Moonwatch, you'll find images, Boy Scouts in the Philippines, gentlemen in suit and tie in South Africa looking through telescopes. And what they do is they'd find something in the sky and they'd let the people in Boston know, and they'd get the cameras out and be able to take images. And so before NASA was even around, citizen science was proving its value in contributing to a cause. And the essence here of the Grand Challenge is this is bigger than NASA's ability to do on its own. We don't want to do it on our own. The excitement of engaging communities that we don't normally talk with to help solve problems that we can't do on our own, that's the opportunity here. An example of how this type of innovation can work, we had a dark matter problem. And through a challenge that was thrown out to a broad community, turns out that a glaciologist noticed what we were looking for and said, aha, very similar. The edge detection and the change for glaciers is very similar to this dark matter problem. And so what happened is he came up with a solution. Would have never been involved in a dark matter conversation before. And that challenge sparked innovation from a totally different field. He didn't end up winning the prize because you ended up having an astrophysicist that saw the improvement and was able to then tweak that improvement for an even greater improvement. But you had breakthrough because of a broad engagement. And so that's really what we're looking to do here, is to start this global conversation and engage in a dialogue with citizenry of the Earth and our national partners around the globe. And really what it does is it allows us to prove that we are smarter than the dinosaurs. This is, again, the one natural disaster that we have the ability to do something about. We have the science, we have the technology. We could have great breakthroughs to improve all of that. But what a great legacy for us to focus on in the next 10 or 15 years, and potentially do it sooner, and be able to share with our kids and our grandkids that this is a problem they don't have to worry about. There are going to be plenty others, but this is one that we took ownership of and decided we would solve together. And so with that, I will gladly take any questions and hopefully spark some solutions in the room today.
How do you know you found 95% if you don't know the last 5%?
It's modeling and statistics, so it's a best guess right now, but we don't know for sure. And so that's where I will say, statistically, somebody might say, it looks like the planet killer happens every 100 million years. It happened within 66 million years. But that doesn't mean that we're going to wait 30 more million years until it happens again. We can only look to the way the climate's changing and seeing that the 500-year flood is no longer every 500 years. And so while we feel confident we've got 95%, we don't know that for sure. And we certainly need to increase the number that we're finding each year. So it's a best guess at this point that we feel good about. But
what's your estimate of the fraction of the 30-meter asteroids that have been found?
About less than 1%, in the 1% range. Yeah. So when you look at the models that say there's down to 30 meters, they'll say the population is so big, and what we've discovered of that estimated population is about 1%. And I'm going to get the numbers, so I won't quote the numbers on that, but the frequency of the smaller are going to be much higher than the 1 in 100 million. So, and the other interesting thing, because we're growing our population so rapidly, the numbers are going to increase because there are going to be more populated areas for people to be impacted by these. So that's a piece in terms of the numbers that folks, I don't think, often consider.
Ballpark, how many asteroids are you actually tracking right now? Like, how many does 95% account for?
We have, I want to say about 10,000 that we have track of. But one of the difficulties with it is that you can find it. You might find one, but you've got to get more glass on it pretty quickly because they're moving by fast. And so if you don't track it well enough to understand its orbit, it'll be gone and you won't know when it's coming back or where it's coming from. And so there really needs to be a concerted effort, and I think that's where we have an exciting opportunity to really build a global network. So we've got a strong US detection ground-based network currently. Europeans are doing great work. There's a great opportunity in Africa, great opportunity to improve Southern Hemisphere coverage. And so having a network when somebody's dark versus daytime, or somebody's cloud covered and can't see, is really where we need to be, so that we can find them and then get tracking on them quickly before they're gone.
With the one earlier this year in Russia, did we have any warning that that was going to happen, or
No.
it was a surprise?
No, and that the difficulty there, the attraction of a space-based telescope that's in a Venus orbit, is that asteroid was coming from the sun, the direction of the sun. And so even if we had some warning or ability, we would have been blinded and not be able to pick it up, because 17 meters is pretty small. Yeah, so no warning.
You have the crowdsourced efforts like the DNA folding and Galaxy Zoo and all that. And what future ones do you envision coming? And maybe it involves asteroids, but what other crowdsourced efforts do you picture?
I'll tell you a pretty fun, it's less, and I think it gets into semantics, whether it's crowdsourcing or citizen science. And I won't go into the details of that. But we had a challenge. The longerons are the structures on the space station that hold the solar arrays. Now, the station's circling the Earth, and it's in night and day every 90 minutes. And so there's a great temperature variation. And so we're starting to notice some limitations in our ability to maximize the sunlight that we're getting on the solar arrays, because we don't want these longerons to get too brittle. And so there was a challenge that was thrown out. And the interesting thing about this challenge is the first step in the challenge was to build a model that would enable a full-up 3D model of the system. That was challenge one. Solve that. Second challenge was to then figure out, how do you maximize the sunlight hitting the arrays without threatening there were a couple of particular joints that were areas of concern. Crowd, if you want to call it the crowd, maybe expert crowd, solved it in days. And the solution is not yet being implemented, but we expect, as this life of the station continues, that it will be. And so we're just starting to kind of play with this concept of the crowd enabling solution to problems that we have. And so part of the, I would say the pressure that I feel as owner of this grand challenge for NASA is to show the agency that this is a culture change shift, that there are smart people out there in other fields that can contribute to the mission and impact and benefit the mission just by having a conversation, and in this and other instances using a challenge to incentivize people. But there are a lot of mechanisms that I really see this as contributing not just at NASA, but in whether it's aerospace industry or industry at large. There's an opportunity here to see that you can really help through this method.
Do we think that the asteroid that caused the KT event and the asteroid that hit in Russia, were these asteroids in near-Earth orbit that we just didn't know about, or were they asteroids in highly elliptical orbits, trans-Neptunian objects, that this was their first time approaching the Earth in 5,000, 10,000 years, and there's no way we could know about them in advance?
Had we had the systems in place, we would have known that these are crossing our path. and that there's about 1 million of them like that out there, down to 30 meters. So it's a very active neighborhood.
Okay.
But that's not to say, somebody brought up the issue of comets. Right now, the Asteroid Grand Challenge is focused on asteroids, but comets also pose hazard as well. So
Russia 1970.
it might be worth expanding the focus. And so that's where I would say that some of the discomfort is that we've got some plan right now, but having conversation leads us into saying, oh, yeah, what about that? We need to add that. And that's not habitual for us at the agency. So this is fun to be playing in.
So that's a perfect prelude sort of into my question. I think that this is a great example, and I think the comet one would be another great example, but there are very few people qualified to take a lot of these problems end to end. How much work is being done to take sort of the base problem, the fundamental problem, and get them in the hands of kids or people that aren't as qualified, getting them to where the experts can focus on the last mile?
Sure. Yeah, and this one in particular as NASA's first grand challenge. So the White House sees grand challenges as a means of innovation. It's a strategic method of innovation. So DOE has a couple of grand challenges. USAID has a couple of grand challenges. The BRAIN initiative that was recently announced this year is also a grand challenge. The Asteroid Grand Challenge is scientifically and technically tough. There's no doubt. We issued a request for information back on the 18th of June when we announced the Grand Challenge. And that request for information was open for 30 days, and it was, as things are, this was released through FedBizOpps and the traditional NASA methods. We got over 402 responses, a lot of which were from folks that we don't normally talk with. We have 96 of those responses that we are gathering the proposers either virtually or in person in Houston at the end of the month, and I'll invite you to watch because we'll be broadcasting live, to bring together those ideas. And in some of those ideas, there is the opportunity to have telescope farms. So I was in a conversation last week, and I'd lived in Manhattan for 7 years, and it didn't even dawn on me. One of the opportunities here is you're talking about getting into the hands of everybody. People in the city aren't going to get a backyard telescope. They're not even going to spend $10,000, $15,000 to get a system that would enable them to do light curve work, let alone have the time and the willingness to dig in. But could you imagine a crowd-funded or crowd-shared set of telescopes in ideal places all over the world where that student or that mom chooses to spend a subscription fee and participate that way, either buying the time so that she can look or donating that time to others so that they can look. And so that's an initial reaction, that just out of the first request in June, we're getting ideas on how to enable the citizenry to engage. I would say that the biggest hurdle is going to be on mitigation. Detection, tracking, characterization, it's a little easier to get one's arms around how people would contribute there. Mitigation's tough. I mean, you're talking about, you don't have to move it a whole lot, but you still got to move it. And technically, that's not an easy task. And so that's where I think there'll be less opportunity for most folks to be able to contribute. But whether it's looking through a galaxy zoo, or whether it's contributing through a crowd-funded effort, the other thing from my perspective is, and why I'm happy to talk to anybody about this, is that who knows what network they have. So you speak to somebody, now they go home and talk to their spouse, their friends, and somebody gets turned on by the idea, and they have a whole network that they can bring into this conversation. So even if it's just talking about it, from my perspective, that's a contribution. Great. Well, thank you so very much for having me. And I invite you to watch through the Asteroid Initiative page. We're having the workshop at the end of the month. 96 fantastic ideas from folks that are wanting to go explore asteroids and protect the planet from them, and encourage you to talk amongst your networks and friends about this very issue. So, yeah, thank you. Take good care.